Hi, this is Carolyn,
This is Sam.
This is Michael.
and we're presenting our Up and Away Bubbles project.
For our project, we decided to test two different recipes and how many bubbles were made per blow for each of the two recipes for bubbles that we used. We conducted 15 different blows per recipe, leading to 30 total blows between the two recipes. The first recipe were store-bought bubbles from the Miracle Store. We got the second recipe off of the internet, and the recipe included half a cup of water, a quarter cup of liquid dish detergent, and 1 teaspoon of sugar. We visually counted how many bubbles were blown when there weren't that many bubbles blown, but when there was a good amount of bubbles that were blown, we took a picture of all the bubbles and counted the bubbles off of the picture. As you can see from the picture we included on the slide, taking pictures of the bubbles was very useful when it got hard to count the bubbles.
For our hypotheses, we let mu1 equal the population mean for the store-bought bubbles, and mu2 equal the population mean for the homemade bubbles. Because our experiment was a two-independent sample, our null hypothesis was mu1 minus mu2 equals 0, and our alternative hypothesis was mu1 minus mu2 does not equal 0. Basically, our null hypothesis says that the store-bought bubbles and homemade bubbles produce the same number of bubbles per blow, while the alternative says that they don't produce the same number of bubbles per blow.
We used SAS to get the descriptive statistics after we finished blowing every observation. We will talk about what these numbers mean to our experiment in further slides, but you can see that the store-bought bubbles produce higher numbers for these statistics. These side-by-side box plots is a graphic summary for our descriptive statistics showed in the previous slide. Just as a reminder, box plot 1 are the store-bought bubbles and box plot 2 are the homemade bubbles. You can visually see that the store-bought bubbles produce more bubbles per blow than the homemade recipe. The diamond in each one of the boxes represent the mean, and the mean is higher up on the graph for the store-bought bubbles than the homemade recipe that we made, which means more bubbles were produced using the store-bought bubbles.
Our SAS code gave us a test statistic of 4.24, 28 degrees of freedom, and a 0.0002 p-value. The p-value identifies if there is a significant difference between the number of bubbles produced by each recipe. A high p-value shows evidence against the alternative hypothesis, while a low p-value shows evidence for it. With a p-value of 0.0002, there is convincing evidence that the population mean store-bought bubbles is different than the population mean homemade bubbles. We used a confidence interval to determine if the parameter of the store-bought bubbles produced more, less, or the same number of bubbles per blow than the homemade recipe. We used a 95% confidence variable, meaning that if random samples are drawn, 95% of the samples will fall within the interval. Our interval has a lower bound of 3.21 and an upper bound of 9.19. Because both numbers are positive, this tells us that we are 95% confident that the population mean of store-bought bubbles is greater than the population mean of homemade bubbles by between 3.21 and 9.19.
Because this was a two-independent sample, there were three assumptions we had to test. First was the random sample, which we knew our data to be random since we recorded our data by counting the number of bubbles. Next, normality was checked by comparing the QQ plots produced by SAS. The data would be bell-shaped on a histogram, and by looking at the picture in the slide, the data is close to the 45-degree line, meaning there is no evidence of non-normality. Finally, we checked the equality of variances by squaring the standard deviations of each recipe to make sure one variance is not double the other. In conclusion, based on the p-value of 0.0002, there is convincing evidence for the alternative hypothesis that the population mean store-bought bubbles is different than the population mean homemade bubbles. For the box plot, there were more bubbles blown from recipe 1 than recipe 2 because there is such a drastic spread and the difference between the means. For the confidence interval, we are 95% confident that the data falls within this interval because it is always positive, which means the recipe for store-bought is greater than the homemade recipe. So overall, we found that the store-bought bubbles produce more bubbles per blow than the homemade bubbles. And this is our citation for our recipe 2.